Hey, how's it going? Is it time? Is it time? I think it's time. Alright, here, let me open this up. I was waiting for it to like pop up or something. What do I... Oh, there we go. Took like a second or two longer than I expected, but I guess it's not that big of a deal. I started recording myself last week, and I did so poorly that I was embarrassed, and I just deleted the video, so I'm sorry. Okay, question 1. Minimum operations to equalize array. You're given an integer array nums of length n in one operation. Choose any subarray and replace each element in that subarray with the bitwise AND of all elements. Oh, okay. So we're slowly eliminating bits. Got it. Return the minimum number of operations required to make all elements of nums equal. Oh, okay. I'm confused. Wouldn't it always be 1 or 0? If min of nums equals max of nums, then return 0, else return 1. Right? 1, 0, cool. All right, accepted. Sweet. I was initially a little confused. All right. Minimum operations to transform string. You're given a string S consisting only of lowercase English letters. You can perform the following operation any number of times, including 0. Choose any character C in the string and replace every occurrence of C with the next lowercase letter in the English alphabet. Okay. Return the minimum number of operations required to transform S into a string consisting of only a All right. Got it. Okay, so we're going to have the highest letter, and then that's just going to... Yeah. So max, M equals max of S. Is it ORD? Is that how you get the character value? Minus ORD of A, return M. Is that right? Okay, 25. Let's see. 2. Now, wait, what? Change Y to Z. Change Z to A. Oh, the next, it's going the other direction. It is going the other direction. All right. Well, I misunderstood. Okay. So, I guess ORD of Z plus 1 minus ORD of min S? Yeah. Except we would want to ignore all A's. So S equals S dot replace A with nothing. If length of S equals 0, then return 0. Otherwise, we do the nonsense. All right. 2 and 0. All right, work. Okay, so I feel like so far I'm off to a good start. This is going pretty well. So it was accepted. There were 950 test cases. That's interesting. Okay. Count bool subarrays. You're given an integer array nums with distinct elements. A subarray nums L through R of nums is called a bool if subarray has length at least 3, The minimum of its two ends is strictly greater than the maximum of all elements in between. Okay, got it. So the two edges have to be bigger than all of the elements inside. Okay, return the number of bool subarrays in nums. Oh no, is this going to be a stack? Okay, it's 10 to the 5th, so I'm not going to be able to do... Let's just try to brute force it and see if... So we're going to say for left in range length nums, and then... I can't do it like that. If I do it like that, then it's going to be n squared and it's going to time out. So I have to somehow know where each of the bowls are. Okay, so... Okay, let's finish writing it and see if we can figure it out after that. So for right in range length nums, and this is going to be left plus 1 would be the next one, 2 what was that sound? That was a very strange sound. Hey, how's it going? I meant to pause the video, not stop the video, but whatever. I still have no idea what that sound was. I think it was a motorcycle, but it sounded like something deflating. I wanted to make sure it wasn't my tire. Anyways, I'm getting sidetracked. Okay, so for right in range, left plus length nums. Okay, so the minimum has to be bigger Okay. As soon as you hit something that is larger than left, then you're done. Left plus, well, no. Left plus 3? Is that right? So this is left. Okay, so left plus 2. Now the only way that it being bigger could be okay is if the ones in the middle are all smaller. So running max equals length of nums minus 1, I guess. Yeah, equals nums of left plus 1. And it has to be strictly greater. So if running max is greater than or equal to nums, let's do this. LE equals nums left is greater than or equal to LE, then continue. Right? There's just nothing that we can do. Okay. Okay, now, right is allowed to be bigger than left, but that would be the end of the run. Right? Because it can't be in the middle. Okay, so Ri equals nums left, no, nums left. Okay. it can be if Ri is greater than or equal to LE, CNT equals 0. CNT plus equals 1, but also break, because there's nothing more that we can do. That has to be the end. Yeah. Now, current min equals min Ri of LE. Okay. And then if running max is less than current min, then CNT plus equals 1, right? Yeah, and then running max equals max of running max, comma, Ri. So this is the version that will produce a timeout. But I just want to see if I got it right. The implementation. Oh, come on. All right. 25314. Okay, 25314. 2, 3, 0. Now I know for a fact that this will time out. I mean, there's absolutely no reason to let it run. I need to figure out if there is some it's like it's as though I need to pre-calculate this somehow. Yeah, it's like a stack of how high it can go and what the location of the next max is. So we start from the right and we say, okay, the highest at this is, this value. And then we keep going down, I guess. And then we could do like a, I don't know, like a binary search on it or something. God, that sounds like a pain. Okay, let's just see the timeout exception. It's in the process of timing out. All right, hidden for this test case. Great, so I can't click use test case. That's annoying. That was part of my plan. So now I got a penalty and no benefit out of it. Count binary palindromic numbers. Okay, you know what? Maybe this would be easier. You're given a non-negative integer n. A non-negative integer is called binary palindromic if its binary representation written without leading zeros reads the same forward and backward. Return the number of integers k such that 0 is lesser than or equal to k is less than or equal to n, and the binary representation of k is a palindrome. Note the number 0 is considered binary palindromic and its representation is 0. So n is 9. The integers k in the range 0 through 9 whose binary representation or palindromes are... All right, that is... This looks way more fun. We'll work on this and then go back to the other one, I suppose. Yeah. Okay, so we'll need to figure out the yeah, the number of digits for each one. And this goes up to 10 to the 15th. What is that? 10 to the 15th. Okay, import math from math, import log. I think he didn't have to do that, but yeah. So log of this divided by log of 2. So up to 49 digits, right? 25, 2 to the 25th. Is this something that we're going to be able to enumerate every single one of them? That's the question. 1, 2, 3, 33 million. I feel like that's kind of pushing it. Okay. Well, you know what they say. If you don't know how to do something, just use recursion. So, palindrome count. I think we're going to have a K remaining digits. And then we're going to have to understand that for odd numbers, there is a shared. It almost seems like we need a different odd and even method, with the understanding that we can put any odd digit that we want in the middle. So I think we have to start with a specific digit. Yeah. I gotta think this one through here. So we're going to have digit, mirror digit, and that's too much to type. Digit and mirror digit. And then we will have one for each. So we'll have to have a leading one, current number, and then n is the max. And obviously we can't exceed n. But we always have a, okay, 0 is lesser than or equal to n is less than or equal to 10 to the 15th. So we're going to have, just remember to add 1 for 0. That's a special case. Okay. So if we can add 1, we add 1. We're going to have to branch. I mean, there's just no other way around it. Okay. If current number is greater than n, then break. Assert D is greater than or equal to mirror. All right. Okay. If digit equals mirror digit, okay. If current number plus digit is lesser than or equal to n, then return 2, because we can do a 1 or a 0. Otherwise, return 1. Probably put this down here. Okay, how long is left in the... Oh my goodness, we have all the time in the world. Okay, Assert D is greater than or equal to M. All right, well, then we just got to start adding. I feel like once we have found something that exceeds the number, then first off, we should test if there's no way that it can overflow. And then we have to... All right. If Cn plus 2 times D if Cn plus 2 times D is lesser than or equal to n. Okay, so our digit is 4, right? So if we added every binary digit, then the most it could possibly be is 7. So if 8 is lesser than or equal to n, then any combination of digits less than that digit is going to be fine. But there's a caveat. We have to mirror them. Yeah, so any old thing will do. I wish that there was a way. No, it's fine. Okay, so while D is lesser than, while D is, okay, so I don't know what to call this, x equals 0. So x plus equals 1, and then D and M, okay. All right, now I'm trying to think, is even versus odd going to be a problem here? And I don't think it is. So let's think about this. You got 4, 1, right? And so 1, 2, 4. So basically your choices are 1, 0, 1, 0, 1, 0, and 1, 1, 1. So 3, basically, which is 2, right? And so you're going to say 4, 1, and this is going to be x equals 1. And then you're going to say 2, 2, and x is going to be equal to 2. And so 3 is 3, right? It's because that very last one is unique. So it is... It's like it doubles it, but every other digit doubles it too. So, oh! This is the one that I was missing. Now it makes sense. 4 makes sense. Okay, so let's try the other one. The other one would be 2, 1. So this is the even numbers. So the options are 1, 1, and 0, 0. Right? Okay, this is going to work. Yeah, so return like that. Okay. Yeah. So now, otherwise, we're going to have to figure out which ones are valid or invalid. And for that, we're going to use the recursion. So let's see here. Okay. So new number add equals D plus M plus current number. New number, I don't know, don't add 0 equals, well, just current number. Okay, this one is always valid. This one is potentially not valid. So, current count equals PC of d divided by 2, comma, m times 2, comma, current number, and n, right? And then, yeah, not break, return 0. Actually, if that's our base case, then we don't need to calculate anything. We can just say return PC plus, and it's almost the same thing, but this is going to be plus d plus m, right? This changes d and m? Yeah, but it only changes d and m in this branch here. So it wouldn't affect this. All right, is that gonna work? Okay. Nope, no. I have to figure out each of them individually. So c equals 1. That's our count, right? Now we're going to do each of the different lengths, but there has to be a leading 1. Okay? So for we're not doing 1 digit. So if n is greater than or equal, if n equals 0, return 1. If n equals 1, return 2. We're not dealing with those. So for b, let's say b equals 2. So while b is lesser than n, while b times 2 is lesser than n. So it is still lesser than n. I don't think we need to do this. I think we can just do this. Okay, so starting number equals, well, just b plus 1, right? Yeah, of course. All right. If starting number is greater than n, then break. Otherwise, we are going to say c plus equals PC of, yeah, well, b divided by 2 to starting number n, and just return c. All right, runtime error. D is greater than or equal to m. Okay, D comma m. Print D comma m comma cn comma n. I gotta see what it's doing here. 1 comma 2. So they've crossed. They've crossed at the lowest level, which makes sense. We need more room in the middle. mean, there wouldn't be a recursion step. Would there? I mean, we're talking about a 2-digit number here, right? So if 3 could also be, if n equals 3, it's not JavaScript. If n equals 3, then return 3, I guess, because 1, 1 is also a palindrome. Then we can start with this being 1 higher. Let's see how that works. Runtime error, assertion error, 2, 4. Two. Okay, I am officially confused. I mean, I didn't mean to get confused, but... Well, and it's not printing anything either, so it's like it's entering this. So B would have to be 4, right? And it's switching to 2. Ah, okay. But where is this coming from? D is greater than or equal to M. Something very strange is going on here. Okay, if D equals M, if Cn returns 0, okay, I guess we need to this does not seem like this should be necessary, but 2259 4299 4299 2499. This is calling this. Or wait, this is... Did I like flip these or something? No. No. Okay, this needs to be a base case. It's not an assertion. If D is lesser than M, then return 0. We are done. Okay, 4. Okay, it is not finding all of them. Okay. It's not finding all of them. That is just terrible. This was supposed to be 3, but that only accounts for... That is right, but that's one. I mean, that's one of our base cases. So. Let's say if n equals 2, then 1, right? No, because you could still do 1. Yeah. And then this would be, yeah, okay. So missing something here. Well, you could do anything less than the amount at any point in time. What if we built the mirror numbers up from 0? Pretty sure these base cases are right. Yeah, 0 is 0, right? And then this is 1 or 0. This is because you can't do 1, 0. That wouldn't work. And then this one is 3 because you can also do 3. Yeah. Okay, so the mirror number, we're going to say left and right. Right? Left and right, except it can't be that. And you can't do 0, 0 because you're not allowed to have preceding zeros. So we need to start with a 3-digit number. So it would be 4 and 1. Right? We have to handle the cases separately, the even and odds. Not necessarily. Okay, we want to construct the maximum number that we can get. Then just know that all of the ones can flip below it. Of course, if the upper one flips, then we know that all the ones below that are fine. No. Enumerating all of them is completely out of the question. That'd be like 33 million choices. And I don't really know a good way to construct the mirror in the first place, so for left power equals in range 2, because 2 to the 2 is 4, yeah. To, I don't know, what did we decide? 25? 2 to the 26th is greater than 10 to the 15th? It's not. Wait, where did I get 26 from? It was 49, right? So 50 is true and 49 is false. Okay, LP. So left bit equals 2 times LP. Now we're going to say C equals 3. Okay. And then right bit, obviously, is 1. If left bit plus right bit is greater than n, then break. If left bit plus right bit exactly equals n, then C plus equals 1 and break. Okay. Now if it's less than, then we have some flexibility. All right. This is looking similar to my previous problem, but I think that the recursion was screwing me up. So let's not try to figure out a fancy base case. Okay. We need to know the maximum. Maximum possible value equals, well, let's start left bit plus right bit. And then while left bit is greater than right bit, okay, look, right now we have something like this, right? And there's going to be a point of symmetry. And we need to figure out how high we can go, because 0 should always be fine. There'll come a point when it's close. I mean, it almost feels like we need the recursion aspect. No, recursion is dumb. Okay. Okay. Num bits equals two? See, we need the free number of bits here, so num bits plus free bits so 0, 1, 2. 0, 1, 2. There would be one free bit. LP divided by 2. 3. There would still be one free bit. But then when you get to 4, there'd be 2 free bits. One of them's a center, yes, but it's still 2 free bits. LP divided by 2. Yeah. Okay. If yeah, okay. If left bit plus right bit plus left bit is lesser than n, then the number of free bits is what we're going to add. So C plus equals Yeah, now 0 should always be fine. I feel like I made a mistake getting rid of the recursion. Do we actually know what we're doing? See, these bits represent an integer, right? That's counting up, and we need to figure out at what value that exceeds the acceptable threshold. And then that's just the number that we add. That seems pretty simple if I just weren't stupid. Okay. So it almost seems like we need like a binary search, right? Okay. Because we have the number of free bits, but then there's an offset. But the offset is still subsidiary. Yeah, it's going to have to be binary search. So calculate n and then offset, right? Can we figure it out from the free bits? No, we can't figure it out from the free bits. We need the offset, we need to move it over, and then we need to take the digits out, add them to the end, and that's going to be our palindromic value. I wonder if I'm making a mistake. What if I just figured it out with preceding zeros and then I just got rid of the zeros out? No, that's stupid too. That doesn't make any sense. The preceding 0 not being allowed is really screwing me up here. Okay. So we'll call it the outside bits, right? So we are going to have something like this, and then we want to fill in. We're going to treat this as an integer. Yeah. So this should be pretty easy, I think. We have to figure out a way to reverse the bits, but hopefully that's not too hard. So leftmost equals n offset, right? And then rightmost equals, how the hell do we do this? I in range. Yeah, because the greatest bit is going to be the furthest left. We'll say rightmost equals 0. No, we have to figure it out in terms of the offset. It's the only way. So for I in range offset. Yeah, I feel like there's going to be a number of... Because there's going to be an inflection point, right? There's going to be a mirror point. We're going to say this is the center, and then this number gets mirrored to over here, and this number gets mirrored to over here, and this number gets mirrored to over here, and that was supposed to be the same length. Let's call it tracking bit. Okay, right tracking bit equals 2, left tracking bit equals tracking bit, and I don't care if there's a redundancy here. So while right tracking bit is less than left tracking bit, okay, then we will say if right tracking bit and n. No. Maybe I'm going about this wrong. Maybe I should specify the range in terms of the final digit. Instead of trying to recalculate it, I should just say, okay, I know what these values are. Let's have a min, let's have a max, and then you figure out the mirror, and I will tell you what the greatest possible bit is. All right. Okay, greatest possible bit. Okay. Assert greatest possible bit times 2 is greater than n. So we're going to have x equals n, and we're going to have right bit equals 2, and then we're going to start filling it in. We're going to say left bit equals greatest possible bit, while left bit is greater than right bit. Left bit divided by equals 2. Right bit times equals 2. Then we will say if left bit and n, then what? Okay, x equals n. If left bit and n, then x or equals right bit, right? And assert 0 equals n and right bit. Okay. So this should give us a value for the interior. I need to verify that this works. This is weird. This is like an internal number. Yeah, so we should be able to return every palindromic number using this if we add it to the base number down here, and then we should be able to use a binary search to figure out if it is in the range that we need. So well, just return x, right? Okay. Get rid of this. I have no idea what that is about. Okay, now this is the internal one, and then it's going to figure out the external one. So I'm going to say low value. What the hell am I talking about? What we can do is we can subtract the outside from the inside. And then the greatest possible bit. Yeah, that would work. That would work. Oh my god, I think I'm onto something here. So C equals 3, and then we're going to say left bit equals 4, right? We're starting with 4. While true. And let's do it like this. Left bit times equals 2. Current number, the outer one, is going to be left bit plus 1. So the first one will be 5, and then the greatest possible bit will be LB divided by 2, right? Yeah, now if Cn is greater than n, then we're going to break. Now we need to look at the inner one. So lowest possible will be, well, 0. It'll always be 0, right? And then the highest possible will be it'll be all ones. It's almost like I need to know how many digits there are. Yeah. Lowest shell equals, it's going to start with 1, right? And then we're going to increase it, but we also need to add 1 to the end. How do I do that? Well, because the number of free bits is only going to increase by 1 every 2 that we add, not by 1 every time. That isn't correct. I am being stupid here. Okay, we're going to say current power equals, what is LS? That's nothing. LS is nothing. Current power equals 1. Then CP plus equals 1. So when we're at 4, it needs to extend half. So 4 is like this, and so we need it to go up to 3, right? Current power, and then when it's this, then it needs to be so 4 is just 1. So when CP is 2, 0, 1, 2, then yeah. So we subtract 2, subtract. I love subtracting. We subtract 2 and what? And then divide 2, the remaining, right? So here, but it needs to be subtract 2. Okay, so free digits equals current power minus 2 current power plus 1 divided by 2, right? Yeah, because when CP is 2, then it's going to be current power is 0. Free digits is going to be this plus 1, which we could accomplish like this. Okay, so CP will initially be 2, so that's going to be 4, so 1, 0, 1, right? We got the 1, so then we are going to get 1. And then it will be 3. So it will be 1, 1, so 2. And then it will be 4, 1, One, 2, 3. CP minus 1. It is plus 1. So this starts at 2. 3 should still be 1. 4 should be 2, but it's a shared digit. Okay, yeah, that's right. So free digits. So high will be, why do I keep doing that? 2 times free digits minus 1, and the whole thing CP divided by 2. Is that right? I don't even know if that's right. This is pissing me off. What if I just found the highest number and then I constructed a mirror palindrome from it instead of like trying to be smart? Being smart sucks. we know that everything less than the highest number isn't going to work, right? That's like a no-duh thing. Well, so I'm right back where I started from, the recursion. Well, maybe recursion was the right way to do it. I can't look at every single value. It doesn't matter whether it's recursion or not. That doesn't work. It's like 2 to the, what was it, 50th power or something? That's 2 to the 25th. Well, maybe I could look at everyone. I'm not making any progress right now. Okay. Okay. I think we actually do want those. All right. So we're doing 3 digits and above. C equals 3, right? Okay. Digit for I in range, I don't know, 2. 2 to the second power is 4, right? All right. Starting number equals 2 to the I plus 1. Okay. Left bit, right bit, max value. Left bit, right bit, max value. Okay, C plus equals R of left bit, right bit, n minus the constraining outer value. Okay. If left bit equals right bit, then something. If left bit is less than right bit, then return 0. Otherwise, left bit is bigger than right bit, which it's supposed to be. Yeah. So if max value is less than is greater than or equal to left bit, then return 2. Else return 0. Assert max value is greater than or equal to 0. If max value is less than 0, then return 0. If max value equals 0, then return 1, because all zeros is the only acceptable thing. Okay, if left bit is lesser than right bit, yeah, then we've exceeded. All right. Return. Yeah, we're either going to set it or we're going to not set it. Those are really the only choices. Okay. Six and one. Wrong answer. Interesting. I thought this simplistic approach would work. Yeah. We're missing 2. I thought this would work. I might just have to throw the towel in. I should have finished the medium problem. Is it too late? Probably. I was struggling a little bit with the medium problem. Left bit, right bit, left bit, right bit. Maybe there's a simple solution in here. Okay, so 3. The 3 are 0, 1, and 1, 1. Then after that, we start with... Oh! No, that's right. That's right, that's right, that's right. See, we have 2 plus 1 is 5, right? Yes. So 4, 2, 1. I don't know why this isn't working. This should be working. This should be working. I mean, if it had given me a timeout, I would have said okay, but... if MB is greater than LB, greater than or equal to the negative... Yeah. No, there's no other way. I don't know. I mean, I'm a little bit frustrated because this looks at every combination. doesn't it? Did I type it wrong? I mean, here we use the digits, here we don't, right? That's not going to help it if the underlying logic is broken. Okay, if Sn is greater than n, then break. That makes sense to me. Okay, let's try to work backwards. We have 11 minutes. Could it be handling the case of an odd number of digits wrong? No, because we terminate. Look. So in this case, LB and RB are, but we have already established that right bit is bigger than left bit, so you can't accidentally be removing the same thing. Minimum value. Left bit gets smaller, right bit gets bigger. Does it cross and are we throwing something away when it crosses? Is that it? That was it. Woohoo! Am I printing? I feel like I put a print statement in. Memory limit exceeded. Use test case. Submit. Recursion depth exceeded. Most likely. Time limit exceeded. Okay. We have 9 minutes. Okay, if LB times 2 is less than MV, then we have free reign, right? We can set every single one of them. So count bits equals 1. then while left bit is less or is greater than right bit, CB plus equals 1, right? So we know that there are at least 1. Okay. CP equals 1. Left bit is greater than right bit. Okay, and then just return 2 times. So now let's say if they were the same, then that would be 1. Yes, because that would never iterate. Now if they were separate by 1, then nothing would be between them. Then it would increase by 1. That would be that's right. That's also 1, which is correct. CB plus equals 1. I'm sorry. Like this. So it's moving. Here, let's see if that's still right. 6. 1, 13. Is 13 right? Is 13 what I was supposed to have? Well, it didn't time out. Damn it. Okay, that just means that I screwed this up. That's fine. I think I'm on the right path here. So if LB times 2 is lesser than MV, then we need to figure out the number of free bits. This is the same thing that I was doing earlier, remember? Free bits. I'm getting too many. Yeah. It has to be strictly greater than. So 32 should become 11. I think I made it worse. It was right before. This logic is screwing it up. Okay. Simple as that. Use test case. Expected 15. 63 gives us 15, right? Oh my God. 5 wrong submissions. Oh my God. I think this requires a stack, and I don't think... I honestly think if I had 20 minutes I could figure it out, but I don't think I can. So, am I even recording? Am I talking to myself? Yes, I am recording. Okay. Okay. Minimum of its 2 ends is strictly greater than the maximum of all elements in between. Each this is kind of like mountain arrays, sort of. I mean, it's like the opposite, but it's sort of the same. there's no way. Maybe with 20 minutes, there's no way